today was to get you introduced to the 3 types of bonds, which I just did. Yeah, I could have made you like do a worksheet or just tell you, but it wouldn't have made as much sense. So even if you didn't get it completely outside, I'm about to explain it again, and you're going to write it down. So types of bonding, 3 kinds. Don't start talking. And electronegativity. Alright, today's the 31st. So, before we talk about the types of bonding, the most important thing that you need to be able to do right now is to find metals and not, we're taking notes, Michael, so you can just take out, please. You need to be able to find metals and nonmetals on the periodic table, and you have to know, when you look at cadmium, for example, it's down in the D block right here. You got to know a couple things about cadmium. First of all, you got to know it's going to make cations. You know, it's going to be positive as an ion. You know, it's involved in ionic bonding, but not covalent. Those types of bonds I just showed you, they're named differently, and they have a bunch of stupid rules that only go with that kind. So, if you can't tell a metal from a non-metal, you're going to be kind of in a little bit of a hurt here coming on. So, metals. Metals, they are found to the left of the metalloid line. This is the metalloid line, this little ladder here that I just showed you that has the peach ones around it. They are found to the left of metalloid line. The vast majority of elements are metals. The metalloid line starts between boron and aluminum and just kind of zigzags down all the way till you get to polonium and astatine and all that. Okay. Left of the metalloid line, they make cations. Remember, cations have a positive charge because cation has a plus sign in the name because they lose electrons. Because, I abbreviated because I'm trying to help you, because they lose electrons. They have a low electronegativity. That is why they lose their electrons. Causes of this. When they play tug of war, they suck. They can't pull on the electrons in a bond very hard, so they give up their electrons. Give you a pencil so you don't write with my expo marker, please. Alright, so that's metals. Non-metals are pretty much the opposite. So let's get that going. So non-metals. So non-metals, opposite, they're on the right of the metalloid line. Okay? They make anions. Anions are negative when gaining electrons. Where do they get the electrons from? What kind of element? Who gives them the electrons? The metals. Okay? This is a two-way street. Okay? You can't have a cation without an anion. Somebody has to give you that electron. Somebody has to take away the electron. Okay? When something is positive, something else is left negative. When y'all won, when the boys won the tug of war, they became negative. They became anions. But the girls gave them the electron, though. Okay? So, anyway, they have a high electronegativity. My pen is not writing very pretty, but I can't do anything about it. This happens some days. Alright, the thing about metals, one more fact about them, they're only in what kind of bond? Which kind of bond only has metals only in? Yeah, that's right. I'm going to give you a ticket here. She said like you meant it. Oh, where's the tickets at? Did y'all pass them around yet?
Yeah.
Oh, okay.
No.
Keep passing them around.
She was supposed to.
Okay, so both kinds of covalent. Oops. There we go. All right, so now that we have that, we're going to go over the three types a little bit more. Ready? I see a lot of people writing, actually. Let me fix this. Ready? Any questions? Can we get off your phone? Thank you so much. Cooper, you back down there? Ah, cool. So moving on. Three kinds of bonds. Three types of bonds. We're going to draw what happened in the tug of war first. So we have ionic. What happened with ionic is we had a non-metal. Let's see. Actually, I'll draw the metal over here. So we have the metal, the boys, they have muscles. That's nice. Okay, he's ready to go swimming. It's fine. So this is my non-metals. And they still rotate. All the electrons go to the metal. And then the non-metal over here.
Give them long hair.
Okay, wait, y'all. I'm about to change your life. I lost an electron. You ready for it? Hang on. I need a little bit more room. This is good. Just wait for it. Are you positive? No, I have a shirt that says this. I will wear the shirt for you tomorrow, baby. You don't get it? When you lose an electron, what is your charge? Thank you. I'm doing my best. I can't do no better. Okay. So anyway, this happens. So if, for example, I have sodium and I have chlorine. Okay. Oh, I did that backwards. Don't judge me. Only God can judge me. Because the metal loses the electron. My bad. If I have chlorine and I have sodium, what ends up happening is the sodium loses an electron. They become 1+, and chlorine becomes chloride and gains the electron. Then they stick together because they're oppositely charged, and that's how we get salt. True story. What happens is the metals lose electrons to nonmetals. And another way of saying this, that's how you're normally going to see it, is electrons are transferred. Electrons are transferred. So if you didn't get what we're doing with tug of war, or you thought of what didn't have a point, I'm trying to get his attention. If you didn't understand the point, what we're doing, that's what the point was. Yeah. Michael, I thought you were using your phone to take notes, but I see that you're watching a boxing match, so I just need you to stop doing that. Alright, next. That's the first kind. Second kind, we have nonpolar. There you go. The next time would be nonpolar. So if you think back to when we were playing tug of war. Huh? Oh, I do need to add something to this slide, so Thomas, thank you for telling me. Today's math is not very hard. All you have to do is subtract. Okay? On that table on page 194, which you went to, 194, everybody went to 194. Find sodium and it has a number up under it. And then find chlorine and it has a number up under it. And subtract those numbers, and I'm going to pick somebody who can tell me what's going on.
You said sodium and what?
The two elements on the board, sodium and chlorine.
Whoa.
You just subtract.
Yes.
Okay.
Oh, sorry. It's me.
Okay, so not now, but in a minute, and on your test too, what's going to happen is you don't have to memorize all these numbers, but we're going to give you the numbers, okay? And then when we play tug of war, if one team is a whole lot stronger than the other one, it's going to steal the ropes, it's going to steal the electrons. So when you're given this data and you subtract it to see who's better at tug of war, the difference, you know, difference in math means whatever happens after you subtract is bigger than 1.7. And so, Jack, you just told me the difference was what? That's bigger than 1.7, right? So when you're doing this here in a minute, we're going to practice this. Write this number down because it's not anywhere else to be found. If the number is bigger than 1.7, then it's ion, okay? So there has to be a difference quite large to be able to completely steal that electron. Or it could be electrons, it could be plural. Okay. Here on out, I'm going to put EN for electronegativity, just because I know that's a long word. You can write EN if you want to. You can remember what it means. Michael, you think? That's really important. Okay. Thank you for getting me to go back, Thomas. I appreciate that, because I forgot. All right, cool. So now that we have that down, EN difference is bigger than 1.7. The next kind of bond is nonpolar covalent. So it's kind of the opposite. Instead of stealing electrons, the nonmetals will share them. Nonpolar covalent. I'm actually going to use red to draw this. So covalent, like cooperate, okay? Sharing. Cooperate, but that's okay. There we go. So we're playing tug of war. I made y'all be nice, even though you don't want to be, and share. Electrons are getting shared. Let's share. So when you go and do the math for this, it's going to have to be less than 0.5, but let's write down the rest. So what happens here is two nonmetals. Metals are only anionic, okay? Two nonmetals share electrons evenly, or mostly evenly. The electronegativity, I'm abbreviating, difference is less than 0.5. And depending on the textbook, these numbers can be a little bit different, but it's good just to have a number to go with. So when you subtract these, you're going to get a difference of less than 0.5. I'm going to get you to do one of those here in a second. So if I have N and O for nitrogen, and let's say we have, I'm going to give you a second, and then I'll get your attention. I need to actually change that to a 2. There we go. Okay. So let's say I have NO2. Right? Thank you. If I have NO2, it does not matter. You know that subtracting thing? That's real easy, right? It does not matter that I have 2 oxygens. This little 2 means that I have 1 nitrogen bonded to 2 oxygens. That 2 does not matter. You're still going to take N and subtract it from O. Like take the big number and subtract the little number. That does not matter. If this had 17 down here, you would take O and minus N. Done. Okay? So find the electronegativity difference. This is called nitrogen dioxide. Find it. So find it. Take your chart. We're going to use that chart a couple times. Actually, we're going to use it several times. .04. So I think it's just 0.4 like that, right? So does that count as nonpolar covalent? Yes. Can you subtract 2 numbers? This is pretty easy, right? Last one. Y'all got this down? Y'all helping Rayon? You good? I'll help you. All right. So last kind. Polar covalent. So this is where boys play tug of war, and then we had more boys, so we pulled a little bit harder, but I didn't let them steal the electrons, but they were still over to one side a little bit more. So this is like a, for the sake of the drawing, when I say drawing, I mean like drawing this. I'm going to draw just a slightly bigger person. So they're both strong, but the electrons are closer to this guy. Okay? So what ends up happening, electrons are shared unevenly. This happens with water, oxygen, and hydrogen bond. Both of those are nonmetals. Hydrogen is a nonmetal. But oxygen is way more electronegative, so it pulls the electrons to its side. So let's imagine this bond has like you know the electron cloud? I'm going to draw the electron cloud of this bond. It looks like this. So around these people, if this is the electrons, they are more on this side. The electrons are more heavily on this side. The rope is farther over here. You see what I'm saying?
No.
You don't?
Yeah.
When y'all play tug of war, Miss Frog's students, you almost won, but I stopped you. The electrons are more to my side of my class. So they were pulling more this way. Electrons are closer to y'all. Y'all had more of the rope. Okay? So what ends up happening, the side where that has the higher electronegativity, look at the difference. Okay, look at hydrogen. Hydrogen's electronegativity is 2.2. Oxygen's is 3.44. Okay? So oxygen can pull on this rope harder. So now let this freak you out. It's really not a big deal. When you got a negative side, that means that this is a negative dipole. This is a lowercase delta in Greek. It doesn't matter. This side's a little bit negative. This side's a little bit positive. So your side was a little bit negative because you almost won, but you didn't. But I didn't let you. I know you would have, blah, blah, blah. But anyway, my class is one type of war all day, by the way. Anyway, so if I look at this, see this is what water looks like. It looks like a little Mickey Mouse, right? The ears are hydrogen. Hydrogen doesn't pull on an electron very hard, and the chin is negative. So what happens when it gets near another one? Like that. Now, anybody want to guess what does this kind of look like? What does that kind of look like? Falls from the sky sometimes, not this week though. No. Yeah. So water makes snowflakes because of the polar covalent bonds it does. The ice crystals get in that shape because Mickey Mouse's chin pulls harder than Mickey Mouse's ears. Like that's why snowflakes look this way. I think they have adenum that would make a snowflake shape. So it's kind of cool. This is also why it hurts when you do a belly flop because they're stuck together. And it's also why it takes so freaking long to boil water to make spaghetti. You can have your meat browned by the time the water isn't already making bubbles yet. Because water is polar. Half of it's positive, half of it's negative. They stick together like little magnets. That's why it's called polar. It's got a positive pole and a negative pole. So these little things, this is the positive pole, or it's called a dipole. Dipole just means there's two poles. 1, 2. Positive pole, it's also called a dipole. This is the negative pole. Anyway, if I have H2O, it doesn't matter that I have two H's. When I calculate the electronegativity difference in that bond, it's going to be, what did I say, 3.44 minus 2.2. So that's 1.24, right? The electronegativity difference is between, look, BN means between 0.5 and 1.7. So it's everything in between ionic and nonpolar. All right, materials people, we're going to do some practice. So I'm going to give you 10 compounds. You're going to figure if it's covalent, ionic, or nonpolar covalent, polar covalent, or ionic. So you're going to get a whiteboard. You're going to put your 10 answers on the whiteboard. So materials people, go. Get sets of 4. Everybody got these notes down? Okay. Yeah, CL's recording. It's okay. I still have this recording for somebody that's out, so heads up on that. That's okay. No, I don't care. I'm just telling you. So find the numbers. It does not matter. This is called the subscript. Doesn't matter what the subscript is. Find the numbers and subtract them, and then look at your notes, right? After this, we're going to play a little game, a little competition. Did everybody get tickets? Which tables did get the tickets?
What's that number under the little
For which number? It's a B or a 3. Doesn't matter the number, though. It is a 3. Aaliyah, go, babe. You're finding these two numbers on the periodic table, 1 to 94. You're subtracting the numbers and looking at your notes. A packet on the way in the door?
Yeah.
Oh, we're out? Yeah. Who else didn't get a packet? Anybody not get a packet today on the way in the door?
Is that a 3 or 2?
It's a 3. It doesn't matter, though, does it? I'll get one. What ended up happening was me.
Oh, okay.
What ended up happening with me and the Scrogs, we shared copies and we just kind of split them up.
Okay.
Everybody else got a paper on the way in the door today. It's non-polar. Yes. Okay, so if you have 2 oxygens, how do you think you have to do number 5? You just take it and subtract it from itself. So if something's bonded to itself, it's like playing tug of war with yourself. It's definitely going to be no difference, right? So it would be 0 because you subtract something from itself. Does that make sense?
What do you do for the 3?
It doesn't matter how many there are. So you just subtract it, like act like it doesn't matter if there's not a number there, if the number's 10. Thomas, do you have to scroll to use a calculator? Because I don't think you do. No, you don't. Get busy, baby. If your phone is distracting you, get a real calculator. Or if I think it's distracting you, you're about to get a real calculator. Thank you. You got a towel right here. You don't have to necessarily put the number. I mean, I would if I was going to find it, but I just want to know the type.
Type of what?
Fine. Are you getting that?
I thought we were just finding the numbers.
Well, we don't just got how to teach us that. So I don't know what that was. You're fine, Jack. I'm messing with you. guys doing pretty good with this? Aaliyah, you okay, honey? Aaliyah, I'm saying today to do the test and you can say.
Oh, shoot, I didn't see the app.
How long will it take? I don't think it'll take more. I have to leave at 4:10 sometimes. You guys have that. You can. What I'll do is just don't keep going. Like if you run out of time, run out of time. Like don't just go past that hour. Alright, we about got it, guys. We do have one more thing to do today. Thomas, where's your answers that you got?
Yeah, that's so
I got tired. I think it's time.
Alright, I'm gonna go over these in about one more minute. Your materials person or somebody that's done, whoever that is going to get one of these papers and one of these Ziploc bags with the neon yellow. If you don't know how to listen, don't be that person. Neon yellow, one piece of paper. Thank you.
She said one of these. One of these.
Okay. And I said just one with the neon yellow. Put the blue one back. Put that one back. It's okay, honey. Here you go. Okay, let's go over this. Okay, so let's go over this KCl. First of all, K is a metal and Cl is a non-metal, so I can already tell you that I know what kind of a bond this is. But what did you get? Just to make sure, please, Jack G. Did everybody get that? Cool. So even if you don't have the electronegativities in front of you, you can tell this is ionic. PS3, Dejanique. Yeah, and look how P and S are right beside each other. That's a good indication that it's probably going to be nonpolar. Thank you. Number 3, IBR. So what kind of bond was this, Thomas? Nonpolar. And so I and BR are right beside each other too, right? Okay. CSO. So cesium is a metal, so this should be ionic. Thomas, I've honestly got to pick you again. That's your name. Yeah, so that makes sense. O2, I had a lot of people ask me about this. When it's N2 or O2 or H2, it's going to be a 0 difference when you subtract. So that's going to be nonpolar covalent. That's actually a true nonpolar. The zero difference. There's no difference in the tug of war. They really do share evenly. All right, RBF. So that's rubidium fluoride. Jacob, what you get on that one?
I was on that one.
Okay, so RB. Okay, F is like 3.98 or something.
Yeah. Oh, I got 3.2.
When you subtracted?
Yeah.
Yeah, that looks about right. So that one's very ionic. SCl2. Those are both. So these are both nonmetals. It's gonna be covalent, right? But I don't know what kind. Cameron, what'd you get?
Which one?
Number 7.
Oh,
Yes. And then you can look at the periodic table, and they're not. Well, they are right beside each other, but chlorine's very. What was the difference? Do you remember? Does anybody have the difference? Point what? 1.3. Okay, chlorine is very electronegative. So I'll buy. Now listen, on number 8, is silver a metal? Is silver a metal?
Yeah.
Okay, it's a metal. Now here's the thing. If it's a metal, it's ionic. I know when you subtract, you get like 1.5, don't you? Right?
What? For silver?
Yeah, this one.
Yeah.
But, right. So listen to me. If it has a metal, it's ionic. But I know sometimes this rule, this 1.7, that's like a ballpark. So if it has a metal, it's ionic, okay? But I threw this one in here on purpose because this is a good rule of thumb, but it doesn't always work, okay? When we do this on the test and we give you these numbers, we'll have something that matches what I'm telling you. But I did want to show you that sometimes it's not exact, okay? SEI2, Hannah? Okay, and they're right beside each other, right? Yeah, they are. NBR3, those are pretty far apart. N's up here, so nitrogen's up here, BR's down here. So this one should be covalent, but it should be polar. Do you see how I'm figuring that out without even looking at the periodic table? Jack, Sheriff.
Which number?
The last one.
NP.
Non-polar.
Or NC.
Is this one non-polar?
Wait, hold on.
Really?
Yeah.
0.08.
Jesus. Yeah. 0.5. It's
Wait.
0.10.
Nitrogen is 3.04. Oh, I meant to pick iodine. All right, you're right. Good job. The halogens are very electronegative, so that's fine. Good job.